So the purpose of this video is to make sure that everyone has a very solid sense of what the square root function looks like when we graph it. We tackled this problem right at the end of the practice that we did in class on Friday, but in case you didn't get there or it just didn't make sense to you, we'll cover it here. So what we're going to do is we are going to graph this function f of x equals the square root of x by making an input-output table. But before we jump over here and just start throwing in input values, it's worth it for us to think about what are we allowed to use as inputs here? Like what values of x are even permissible? Which effectively means what's the domain? And so hopefully you'll recognize using real numbers, I'm only allowed to input positive, non-negative values here. I can put in 0, I can put in 1, I can put in 15, but I shouldn't be putting in things like -9 because the square root function is not going to work well for that. So the best input values for me to use here would be things that are perfect squares. It'll work well for me to use things like 0 and 1, 4, maybe 9. We could keep going. I could use 16 or 25 as an input value, but my x-axis here doesn't really accommodate that well, so I'm going to use those 4 input values. Right? So, we now proceed to compute what is the output for 0. What is f of 0? Well, it would be the square root of 0, which is 0. Okay? We can then look at f of 1. Right? F of 1 would be the square root of 1, which is 1. So we have an output value of 1 here. Right? We could then do f of 4, which would be the square root of 4. The square root of 4 is, of course, 2. And for the last one, I don't think I need to write the computation down for that one. The square root of 9 is 3. Right? So if we now take each of these input-output combinations, the input 0, output 0, input 1, output 1, if we take each of those and represent them as a point, we'll have the point 0, 0. Then we'll have the point 1, 1. Next we'll have the point 4, 2. And finally we'll have the point 9, 3. And the next step in making a graph is generally to sort of go through and connect those points. And what we want to do is we want to start the graph here and sort of connect through that way. You'll notice I have an arrow going to the right because I could certainly keep plugging in, I could keep inputting larger and larger values of x, whereas I can't really input values over here. Okay? One thing that I pointed out in class on Friday and is worth considering is now that you have this graph, we can sort of do some interesting things. Now that you have a graph, if someone were to ask you the question, what is the square root of 5? We could actually answer that with some level of certainty. If I look at my graph and go to an input value of 5, the output value here seems to be about 2.2. Our graph can be used to evaluate a function sort of without having to use a calculator, without having to sort of think through what the computation for that would be. So anytime we work with a function that has a square root in it, this is what we're going to be looking at. This is what the parent function for the square root graph. This is what the graph for the parent function of the square root of x looks like.